We saw while learning exponents that a into b raised to power m is equal to a raised to power n into b raised to power n. Now, would that also be true if I replace this exponent to a fraction? For example, would a into b raised to power 1 by m be equal to a raised to power 1 by m into b raised to power 1 by m? Not sure, but I think we can verify it. We can just take certain values for a, b and n and check this. Let's take a to be 8, b to be 27 and m to be 3. Now, I need to check if this would be equal to 8 raised to power 1 by 3 into 27 raised to power 1 by 3. Let's go for the left hand side first. 8 into 27 is 260. Let's keep the right hand side as it is. Now, I need to find this one. So, we know that 216 raised to power 1 by 3. That is actually the cube root of 216. So, let's find out the cube root using prime factorization. So, we can start with 2. So, this would be 108, okay. Again a 2, it would be 5 and 4, 54. Again a 2 and this would be 27. Now, 3 into 9 is 27, 3 into 3 is 9 and then again a 3. So, 216 is equal to, there are 3 2's and 3 3's. So, 2 raised to power 3 into 3 raised to power 3. Now, as per this law, it would be equal to 2 into 3 raised to power 3. Since I need to find 216 raised to the power 1 by 3. So, we will have, on the right hand side, we will have 2 into 3 raised to power 3 raised to the power 1 by 3. This 3 and 1 by 3 cancel out, which will give us 2 into 3, that is 6. Okay, so we have 6 on the left hand side. Cube root of 8 is 2 and cube root of 27 is 3. So, the equation is equal. That means this is verified. So, we can just say that a into b raised to power 1 by 3 is actually equal to a raised to power 1 by 3 into b raised to power 1 by 3, or cube root of a into b is equal to cube root of a into cube root of b, right? Now, let us look at one more thing. A upon b raised to power 3, what would this be equal to? We know that if something has a power of 3, we multiply that value to itself 3 times. So, this will be equal to a upon b into a upon b into a upon b. Now, if you look at the numerator, you have a into a, which is a cube. Similarly, b into b is b cube. So, this is equal to a cube upon b cube. We can quickly verify this through an example as well. Let's say a is 12 and b is 10. We need to check if the cube of this is equal to 12 cube upon 10 cube. 12 upon 10 is 1.2. And over here on the right hand side, the cube of 12 is 1728. Cube of 10 is 1000. So, 1.2 into 1.2 into 1.2 is 1.728. On the right hand side, we have 1.728 as well. So, this is valid, right? Now, once again, if I replace this exponent to a fraction, it would be true as well, right? So, a upon b raised to the power 1 upon 3 would be equal to a raised to power 1 upon 3 divided by b raised to power 1 upon 3. That means we have that the cube root of a upon b is equal to cube root of a divided by cube root of b. Now, once we have these identities, it becomes a lot easier for us to solve the questions. For example, if we need to find the value of this, we know we can use the identity over here, and this will be equal to cube root of 64 into cube root of 1 to 5. Now, the cube root of 64 is 4 and the cube root of 1 to 5 is 5. So, 4 into 5, that is 20. Becomes easier, right? Let's take another example. Now, we need to find the cube of 9 upon 4. According to the identity, this is equal to 9 cube upon 4 cube. Cube of 9 is 9 to 9 is 81. 81 into 9 is 7 to 9. And cube of 4 is 64. Let's head to one more example. We need to find the cube root of 27 divided by 216. Now, this is equal to cube root of 27 divided by cube root of 216. cube root of 27 is 3 and cube root of 216 is 6. Now we can simplify this and we'll get 1 by 2.